Welcome back to RC Model Reviews, a treat spécial for you today because I've cleared a space on the bench. See if I take this away, there is a space, but we're using it up because I've got the scales that don't show the blood. Doing a little thing today because basically I have this, this quadcopter here, this Foxeer Aura 7. Let me get it into shot. You've seen it, I reviewed it, I quite like it, seems to fly very well. But I was flying it with 1300 mAh 6S. And I get over 6 minutes. Then I built a 3000 milliamp lithium-ion pack, and I got more like 16 minutes, I remember now, 16 minutes. But I want more. Enough is never enough. So I'm going to build another pack today. I'm going to build a pack, well, let me see. These were the cells I used for the 3000 milliamp pack. These are the LG cells. They are 3000 milliamps. And they can deliver 20 amps continuous. So if you're just cruising, they are adequate, but they do come down a bit warm and you don't have much room for punching without really sort of eating into the battery's life. They don't like being abused too much, but for just cruising, you could get by with these. 3000 milliamps. And these things, let me turn on the scales that don't show the blood. What do they weigh? They weigh 46 grams, right? So to build a bigger pack, I'm going to use these. Now these are 21700 cells. To put them side by side, give you a comparison, they're a little bit bigger. Not that much bigger, but a little bit bigger. Do they weigh more? Let's have a look. By Jinkos they do. They're 69 grams, and I've already forgotten, 69 grams versus 46 grams. So they're about 50% heavier. My quick mental arithmetic, which is probably wrong. But you only get 1000 milliamps more, so that you only get 30% more capacity for 50% more weight. That doesn't sound like a very good deal until you realize that while these batteries are limited to 20 amps continuous, these will do 45. Now 45 amps is a lot, even in a quadcopter world. 45 amps lets you punch a little harder, fly a little faster without risk of damaging or overheating the batteries. But more importantly, these have a lower internal resistance. And what does that mean? Well, it means that when you are using these batteries, a certain percentage of the energy in them gets turned into heat. They get warm because they have an internal resistance. That resistance has to be overcome, and energy is wasted, turned to heat, to overcome that resistance. The internal resistance of these is much, much lower, so you actually get to use more of your 4000 milliamps. With this, I think I did some calculations, I can't remember what they were, I'll put them on the screen perhaps if I remember, but with this, quite a significant portion of the energy you store in that battery, of those 3000 milliamps, actually just goes in heating up the cell when you're using it. With these, far less of the energy you put in, far less of the 4000 milliamps will actually go to heating up the cell, and more of it will be available to the motors and the rest of the stuff on the quadcopter. So this will actually give, hopefully, a sensible amount more endurance. But of course, I've got all these cells here, which I bought from 18650 Batteries New Zealand, I think they were. I'll put a link in the description. They did really good service. If you live in New Zealand, great place to get your lithium-ion cells. They perform very well, the company, and so far, let's see whether these cells perform very well. But I've got all these cells, I have to connect them into a pack. It's a 6S machine, I've got 6 cells, and just to give you an indication, a 6S 4000 milliampere hour battery pack in New Zealand costs about this much. I'll put it here, look at this, this is what you pay for in New Zealand. Now I ordered these cells, 6 of them, 4000 milliamps, and it cost me, I think it was under $70 New Zealand, including shipping and delivery. So it's a lot cheaper to make your own 4000 milliamp lithium ion packs than it is to buy a lipo of the same capacity. And if you don't need super high current, now these are 4000, so these are really only about 12C, 12.5C, because you're sucking 45 amps from, no, 11C, 45 amps from a 4000 milliampere hour battery. So they're not high C, but because you've got more capacity, the actual amount of current you can draw is higher. Right, so what I'm going to do now is I'm going to solder them together to make a 6S 4000 milliampere hour pack. I'm just going to show you some little bits of the project while I'm doing it. Not going to explain it in detail. I think I've already done a video on RC Model Reviews showing how to build your own lithium-ion pack. If I can find it, I'll put it in the little thing that might pop up there. Otherwise, I've got no idea. But anyway, let's get on, let's build this battery, and more importantly, let's see what difference it makes to the endurance of the Foxeer Aura 7. Enjoy the vista that is the bench. Yeah, I'll tidy it up soon one day. It's spring, well, it's just finished spring, too late for a spring clean. But anyway, let's have a look. What are you going to need to make one of these batteries? Well, you're going to need an XT60 because we're using XT60 connectors, and it's going to have some leads on it. Here's one I've pulled out of an old battery that was stuffed. Don't throw your old batteries away. Cut the leads off, cut all the bits off that you might need. We're going to need some wire to connect the individual cells in series because the 6S pack is 6 S. The S stands for series. I've got some wire there. It doesn't have to be as thick as the main leads because it's going to be very, very short. You also need a balance lead. Now, you could use a balance lead from an old discarded 6L pack. I'm going to build my own. I have some of these little connectors here and the pins that go with them. Somewhere, I know where they'll turn up, don't worry, they're here somewhere. Anyway, so I will make up my own, and for that I use some silicon wire, which I'll make up the 7 wires for the balance lead. But I'm going to solder the batteries together, put the battery together first before I do the balance lead, because then I can get the wires just the right length. Now, as to which way to put the batteries, there's no easy way to put them together. I'm going to make a block. It's going to be a block of lithium because I don't have any other shape that I can really use that's going to fit on the Aura 7, so it's going to be a little bit tall, but hey ho, it doesn't matter. I'm only going to put them together with little tiny dabs of hot glue, so if I need to I can pull it apart and rearrange them later. Don't have any heat shrink that's going to fit around these at the moment, so I just wrap them up in tape. That works fine. So first thing to do with your batteries is to you'll also need a soldering iron, or if you live in America, don't get a soldering iron, get a soldering iron, because you don't need the L in America. But there you go, nice soldering iron. I've already done tips on how to solder, and I will be soldering these. I'm not going to use spot welders and things. Most people don't have a spot welder. You don't, but most people have access to a soldering iron. So get yourself a soldering iron, a good one. This is a Heiko, reputable brand. It has to be a reasonably powerful one because a lot of metal here, and you want to solder the wires on very, very quickly so that it doesn't overheat the battery. If it takes more than 3 or 4 seconds, it's taking too long. And so you'll see when I do it, very quick, and that's just something you get with time. Practice, 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 practice. Just practice until you can get it right. Practice on some old flat batteries if you've got them, until you've got it pretty much right, and then you can use it on your new batteries. You won't overheat them or destroy them. They're pretty tough really, but one thing to remember, don't do it with fully charged batteries. If these things go off, you can have a bit of a problem. Keep a fire extinguisher nearby, even if you think these are, pretty much depleted. Keep a fire extinguisher, or a bucket of sand would be good, because fire extinguishers don't put out lipo fires. Keep a bucket of sand or some other way of quenching the flames. Even if you throw these in a bucket of water when they're going, it won't put the fire out. So you need to make sure you got something you can smother it with, sand and smoke and stuff will still come out, but at least it won't burn your house down. Right. Now, first thing to do, or you'll also need, I should have worked this out better, shouldn't I, with your requirements. You need some solder, or if you live in America, solder. Now, a very nice viewer, sent me this quite some time ago, and I have been whooping through it. Fantastic solder. It's the Kester brand. It is leaded solder. Do not use hippie tin-free or lead-free solder. Hippie lead-free solder is just for people that can't solder properly. This is the best stuff. Lead makes soldering so much easier, and you don't get tin whiskers and other problems. So if you want to make your own life easier, a nice leaded solder is the way to go. Now, as I say, first thing to do, we want to prepare all of our cells, all 6 cells. We want to prepare them because we want to solder to them. You want to get rid of any tarnish that might have grown, over time. These things tarnish. If the cells aren't brand new, they'll have a bit of tarnish on them. You want to get something, you can use a bit of sandpaper. Sometimes I'm just using a Scotch pad here. This is enough just to break the tarnish off the top of those cells. I'll just do this one as an example. So I've kind of got that shiny. Oh, shiny, see that? Yep. And now I'm just going to get my soldering iron, or my soldering iron. Hopefully the angle of the camera is all right. I'm going to apply the soldering iron to the top of the battery and then feed the solder in. So I'm not going to heat the solder and drop it on. I want the battery to be hot, and I want the solder to melt so that alloys with the top of the battery. Let's see if we can do that. And what you have to do also is a little bit of mechanical movement here. A little bit of there we go. That's it, done. You can lick your finger and put it on, just to make sure it's not too hot. Here you go. Look at that. I don't know if it's going to focus, but that's a perfect little dab of solder on there. See how it took just 2 or 3 seconds? That's all it took. If you've got the right tools and you've practiced, you can do it too. Really, really easy. Not a problem. You need to do the same on the bottom as well. Here's my little Scotch pad. The bottom's usually a bit harder because the top of the battery is actually a separate plate that's held slightly above the main battery, and that means that the heat doesn't get wicked away quite so quickly. The bottom is a slightly different kettle of fish because this is actually the bottom of the battery, so you need to be even more careful here that you're not going to take too long and get things overheated. And let me see if I can do that. Bit of solder in there, bit of mechanical action. You've got to swirl it round. It's starting to go. No, taking too long. Let it cool down. If it takes longer than that, you're doing it wrong. I did it wrong. And what it is that this isn't actually clean enough. I'm going to have to use some abrasive on there. The Scotch pad isn't enough to get the oxide layer off. So I'm going to get some sandpaper. Try that. Here we go. I've got a tiny bit of sandpaper. I can just give that a bit of a scratch, get the oxide layer off. And we'll see if we can do it this time. And if you can't do it, can't do it, if you try, no matter how hard you try, your soldering iron's probably not hot enough. You need one with a lot of, not just heat, not just temperature, but heat. Heat is the important thing. So let's have another go. Yes, this time, brilliant, fantastic. See how little time that took? And there we go, we've got a nice blob of solder sitting there, ready to have our wire attached. So remember, if it doesn't solder within the time frame that you saw the first time, just abandon it, let the cell cool down, do it again. That way you won't wreck the cells. So we tin each end of all the cells and then we're ready to go. I'm going to do a jump cut because you don't want to watch me doing this. It's boring as bat poo. There you go. Just some tiny dabs of hot glue, and I put some masking tape around it as well, just to hold it all together. While I then tin the rest of these negative terminals on the batteries, just makes it so much easier. I'm going to put my granny glasses on. Makes it so much easier if you have plenty of physical support while you're doing this, because you do need to use a little bit of elbow grease just to get that. There you go. Look at that, beautiful. Just to get the solder to take sometimes just a little bit of elbow grease. There you go, beautiful. Look at that. So this happens really quickly when you've got that surface prepared. Not really more than 2 or 3 seconds maximum to get that nice shiny blob of solder on there. There we go. There we go. In fact, I'll just touch that one up a little bit. There we go. Beautiful. Look, oops, sorry, banged the camera. So there we go. There are all the ends of the cells tinned, ready for us to connect the wires that will put all these 6 cells in series and the balancing wires that will go off to our balancing plug. So far, pretty straightforward. I should mention that you put them together, it's like positive, negative, positive, negative, so that you can put they're in series. Don't put them all going the same way, whatever you do. They have to be alternate. Just do them in pairs first. Do pairs with these cells in alternate directions, and then line up them so that you have like positive, negative, positive, negative, positive, negative, so that there's no 2 positives directly opposite each other. You can work it out. It's pretty simple. Just, the cells have to be opposite each other to make the shortest possible run for the wires that are going to connect them in series, because you don't want too much wire. Every little bit of wire increases the internal resistance of the battery, albeit only by a tiny fraction. But we want to make the best job we can. Right, now decide where you're going to have your main battery coming out, your main lead, your XT60 lead coming out. I'm going to have it on these two at the bottom of the battery, because the battery is going to sit on the quad like this, and I want the leads to come out here and plug in. It's going to make it a tall battery, but when you've got this many cells, there's not many options, unfortunately. It's either very tall or very wide, and of course, I think tall's better, because if you're flying through the air, there's less drag from a tall pack than there is from a wide pack. So I'm going to choose this end here, and I'm going to tin these wires and solder them on. That's the output of our battery that'll go off to the quadcopter. And to do that, of course, we have to bare back the insulation a little bit. I use a modelling knife. You can use side cutters or even a purpose-built stripper if you want to, but those girls are expensive, so I just use a modelling knife. And then, of course, once you've pared one back, you need to tin it with the good old solder. And again, you need that nice high heat, not necessarily high temperature, but high heat, so that it doesn't just all go cold when you start melting the solder onto the end of the wire. And with my Parkinson's, even with my pills today, I'm still a bit shaky, so please excuse that. And get that pretty well loaded up. Yep, there you go. Now, as you can see, hopefully that's pretty loaded up with solder, because we're going to sweat it. It's called sweating. We're going to put that on there, just put the heat on, the solder will melt together. The solder on the wire and the solder on the top of that cell will just melt together. Actually, that's not very well tinned. There's still a bit on the bottom that needs some attention, so I will add some more on the bottom. This is probably one of the hardest things to do if your gear's not very good, because the heat will all flow away and the solder won't melt onto the wire. There we go. That's brilliant. Ooh, it's looking a bit tatty, but it'll do. It'll do. That's just fine. No problems. Do the same with the negative wire. Got to have both to tango. In fact, one of the problems when you reuse these wires, sometimes the wire is actually pretty bad, and the wire on this, it's not good wire. Oh, and I notice there's a little bit of a. I shouldn't use this. It's already got an insulation that's been damaged in a previous life. But let's see what happens. Try and get it right. Yep. You might have to use quite a bit of solder to make sure it's all flowed in there and it's all nice capillary actions, drawn it into the wire itself. There you go. That seems I'm happy enough with that. Remember, this isn't a really high C pack, so you're only going to get 40 amps out of here, 45 amps most of the time, so I'm not too worried about that. So now I'm going to sweat it. No sweat, but I'm going to sweat it. This is where we put the iron on the top, melt the solder, and it should then melt the solder on the battery underneath. And we can tell that because you'll see it'll start to move when we wiggle it. Ooh. Ah. There we go, that is melted, that has sweated. It's not a nice glowy, nice rounded blob, but the underneath the alloying has taken place and that wire is very firmly attached to the bottom of that battery. I do the same with the positive side. I'm trying to do this so that you can see what's happening in shot. Ooh, here we go. Bring this down and wiggle a little bit, and yep, there we go, the pool of solder. Ah, flip, that's hot. Just take care, you don't burn yourself. Oh no, so I'm going to put a bit more solder on that because it was so hot that it's actually moved a little bit. So let's heat that up, a bit more solder. Voila, it is done. And that's it. Don't take any longer. Oh, sorry, out of shot. Don't take any longer than that because you will overheat the cells if you spend too much time. And again, that's why you want a soldering iron with lots of heat. Heat is the ability to provide that thermal energy. If you have an iron that doesn't have enough heat capacity, then even no matter how high you wind the temperature, it'll suck the heat out of the tip and you just won't get that alloying. So good tools are the key to good results when you're soldering, and it's really worth spending money on a decent soldering iron. And you notice, just to go over some of the tips again, this has got a flat tip. It's not a round, it's not a conical tip. So many soldering irons ship with a tiny conical tip, which means there's not enough area and contact to transfer the heat. You want the big flat tip when you're doing this, so all the heat transfers as quickly as possible. There we go. So there's our outlet. Remember, positive, negative. Don't get in the wrong way around. It will ruin your day and your quadcopter. Now what we're going to do is put in the links that connect our cells in series. So we'll have a link from there to there, and a link from there to there, and a link from there to there. So I'll go ahead and do that. I'm not going to bore you. Jump cut. Job done. Now you can see this is the power out here. I put links there and there, and on the bottom, links there and there, there and there, there and there. See, that's it. And so that's all wired in series. I'll try and remember to put a diagram on the screen, perhaps showing you how these are wired up, but you can probably work it out from here. Just make sure that you're not going to be joining both ends of a pair of cells, because that will let all the smoke out and it'll ruin your day. So that's basically the pack. But of course we need a balance lead, because you should never charge a lithium pack without a balanced charger and without a balance lead. Otherwise, really bad things can happen. So I'm now going to make up the balance lead and wire that in as well. So here is our new battery pack with the balance lead all attached. And before you plug it into a charger, you have to do some basic tests, which will require you to have a multimeter like the one I have here. Can I get this to stand up so you can read it? I don't know. Can I get it in shot? Maybe you can read it there. And what you do is, first of all, you got to check and make sure that there is the right voltage and the right polarity across the XT60. And this says 20.62 volts, which is pretty close, I think. Then what you have to do is measure the voltages on the balance lead to make sure they go up in the correct order. Nothing worse than getting a couple of wires crossed. That'll ruin your day. So I'm starting from the negative. And if I go into the negative of the balance lead, it should give me 0 volts. And it does. The next should be 3 point something. 3.4. Next should be 6 or 7. There you go. The next should be 9 or 10. There you go. Next should be 14 or so, 13 or 14. Then we want 17 or 18. And finally, the full battery voltage. So we've got all the balance lead wires connected correctly. The battery looks a bit rough, but hey, this is just so to test something. What you would really want to do is wrap this in heat shrink with some card over each end, so these connections are not going to be rubbing against carbon or anything and perhaps short out. I'm going to wrap the whole damn thing in tape because I'm cheap and I don't have any heat shrink the right size. So I'm going to do that, and I'm going to put it on the charger. I'm going to charge it up, and let's see how many minutes we can get out of the Foxeer Aura 7 with our own 4,000 milliamp lithium-ion battery pack. Okay, Arnie, put that stogie out. Grab the radio. Come spot for me, man.
No problem.
Let's go flying. Let's see how long this battery will last. So there we go. That is the homemade 4000 mAh lithium-ion pack on the Foxeer Aura 7. And I have to say, I turned up the video, I wound the DJI up to 1200 milliwatts because I wanted to have a bit more liberty and freedom as to where I flew. Everywhere the spotter could see, I was flying, so that was all right. Now, as I expected, this 4000 mAh pack gave me 20 minutes, and there was a bit left in the tank, but you'd want to be home before you reach that level. There was about 2.8 volts under load. Lithium ions will go down to 2.5, but having 0.3 volts at the bottom there, it's not a lot of reserve. So let's say it is 20 minutes. It's a comfortable 20 minutes. As long as you plan your flight, that's more than enough. Now, I noticed that this did have more pep. It had more punch right out of the launch because these batteries are lower internal resistance. I think when I measured them, about 10 to 11 milliohms, which is, pretty good. I think the other ones, the 3000 milliamps, are up around the 15, 16 milliamps. So it's a 40% reduction or 30% reduction in internal resistance, makes it peppier. Now as I expected, I got 20 minutes of flight time. I didn't expect much more because there's a law of diminishing returns with batteries. When you put a bigger battery on a quad, you don't always get a longer flight time because bigger batteries weigh more, which means you've got to use more energy just keeping the thing in the air. And you reach a point where you actually start going backwards. If you put too big a battery on, you just don't get as much flight time because way too much power is wasted holding that thing in the air. This is probably just about at that point where any more capacity and this would fly for a shorter length of time. But 20 minutes, it's fine. I wouldn't fly this for 20 minutes with this battery. The reason I would use this battery rather than the 3000 is that it gives me more options when I'm flying. It gives me more pep, more punch. I can do things that wouldn't have been easy to do with the 3000 because this will deliver more energy on demand, more power on demand. Yeah, it got pretty soft towards the end, but you expect that when the voltage of each cell is down to 2.8 volts. But never was it in a position where I felt I needed more power. I was going to, hit the ground or something. It was great. It was fantastic. So there, if you want to build your own battery, there's a bit, you've seen the tips, and I'm sure I did another video on this, but I forget what I make. And so if you've got questions about the whole process, go down, down there, and ask, and I'll be delighted to give you all the help I can. As I say, this cost me, I think, $67 plus the XT60 lead and the balance lead. And compared to commercial prices for lithium polymers, which wouldn't give you as much flight time, yeah, that's not a bad return on my investment. So there you go. Nothing else to say really. I still like the Aura 7. I think it's a good little quad. Well, good 7-inch quad, not so little, is it? And it flies really well. You'll see more of this on my X-Jet channel coming up because I will be using this perhaps as the rescue quad. The beauty being that if I put this battery on, I can fly all day, short flights, 4 or 5 minutes, without having to recharge. Bonus points for that. Anyway, thank you for watching. Thank you to my Patreon supporters. You give me the freedom to do this without a commercial imperative. No mid-roll ads in my videos and no affiliate links in the description. I'm not trying to flog you a damn thing because I don't make a penny out of anything other than my Patreon supporters and the ads that YouTube put on the videos. And I only let them put pre-rolls on. I'm not going to annoy you with mid-rolls. So thank you for watching. It's nearly Christmas. Best wishes of the season. There'll be more videos before Christmas. I have finally my walk snail DJI analog comparison, and you might be interested in that one, especially now that DJI have launched the O3 air unit and the goggles too, and we'll talk about remote ID and a few other things. But yeah, I'll tell you what I think is the best FPV system to buy at the moment. Not necessarily the best performing, but the best. And I'll explain why in a video coming up on this channel very soon. Subscribe if you do not want to miss that. Thanks for watching. Bye for now. Arnie, pack up, mate. We're going.
Bruce is like my favorite guy of all time. I was hanging out with him in his hot tub, smoking a stogie, and I'm like, what's going on, Bruce? And he's like, yeah, this is me, Bruce, right? And I'm doing all these things over there, doing these things over here. And I have to say, Bruce, I love your work. It's absolutely fantastic.